Hello, Dr. Sangsu. I'm Anushraj Dasan. I'm here to present my term project on Windows operating system. So this is basically the outline of what my presentation is going to be. It's going to consist of what is Windows OS, the brief history, design goals, process and memory management, device and file management, security management, user interface, and what companies are currently involved in this line of business, and the future direction and conclusion. So now let us look at what is Windows OS. Microsoft Corporation developed an operating system to run on personal computers, mobile devices, servers, and gaming consoles known as Microsoft Windows and also known as Windows OS. Windows OS featured the first graphical user interface, multitasking, virtual memory management, and peripheral device support. And now let's see what is the brief history of the Windows OS. Microsoft Windows' first version disk operating system was launched in 1985, featuring a command line as a graphical user interface. In the latter versions, Microsoft introduced menu options and buttons in the Windows OS and interpreted user actions as commands in binary language. Over the period of time, Microsoft improved the user interface on operating system to render different color schemes. Computer hardware advancements allowed Windows OS to work with the game designs and touch sensitive displays. The design goals of the Windows OS is um, mobility is one of the major design goals of Windows OS to run mobile devices like tablets, which will give the opportunity for the users to use Windows OS on to go. Security. Windows OS lacks in the security over the layers, and users have to run custom security applications to prevent from malware. In Windows 8 OS, Microsoft introduced Microsoft Security Application with the OS to increase performance. Streamlining Windows OS upgrade process. Until Windows XP, a newer version of the OS can only be installed using external hardware. In the latest version of the Windows OS can be upgraded directly from the OS downloading from the internet. The other design goals are Windows App Store. In the previous versions of Windows OS, any application had to be downloaded from the provider. In the latest version, Microsoft invested a lot on the App Store to consolidate all the applications in one place, which will give users credibility and security. Multi-process support. Supporting Intel and ARM process will allow many manufacturers to build tablets and mobile devices using Windows OS. And the other thing is improved energy efficiency. All the previous versions of Windows are a power hog. In recent times, all the users are preferring mobile. This becomes one of the major goals of the Windows OS to consume less power to be in the mobile market. So now let's look at the process management. A program is a job that is in a passive mode. A process is a job that is in an active mode. In other words, a program during execution is called a process. A process is subdivided into more executable units known as threads. Threads are scheduled for processing based on multiple factors like CPU, memory availability, priority, etc. A process containing multiple cores can handle different threads at the same time. Process methods are majorly characterized into single thread and multi thread processes. So now let's look at what is single thread. Single thread process executes sequentially, and it is achieved using a program counter that holds the address of the next instruction to execute. Multi-thread process handles multiple processes concurrently like user requests. Background process and foreground process, this is achieved using a program counter per thread. The priority to the process ready for execution are assigned by Windows System Resource Manager. A process that is matching the criteria is assigned the available CPU bandwidth. Resource management will come into play only when the CPU usage is higher than 70%. As per the process management, Windows OS will perform the following tasks. The first task is it creates the creation and deletion of the process, suspension and resumption of the process, synchronization communication process, and process deadlock handling. Processes are characterized into two streams by the Windows OS. One is the active process and the second one is the passive process. Now let's look at the memory management of the Windows OS. For any program to execute, it needs a set of instructions. For a computer to work, it needs that instruction in the format of binary, that is zeros and ones. The process needs instructions to perform any functionality. The place to store instructions data is called the memory device. As with the technology advancement, the memory devices are transformed from gigantic components to thumb drives, hard disks, and now in cloud storage. Windows OS operates both on ROM and RAM. ROM is the permanent memory where the user data is stored forever, but the RAM helps the OS to function faster with readily available memory. The logical address space separates the physical address space to manage memory properly. Both logical and physical address are same in load time and compile time. However, they differ in execution time. The logical address space separates the physical address space to manage memory properly. Both logical and physical address are same in load time and compile time. However, they differ in execution time. 32-bit Windows OS have about 4 GB of memory. 64-bit Windows OS have 8 TB of virtual address. At a single instant, Windows OS and accommodate multiple actions user can perform. This is achieved by thread. In terms of memory, a single thread cannot access memory used by other process. This way, Windows OS protects programs from getting corrupted. Windows memory management mainly has three responsibilities. The first one is map virtual address of a process to a physical memory. This way, the correct physical address will be referred to when a thread or user action reads or writes any data to virtual address space. And the second one is when the system code or thread or user action uses more than available physical memory, Windows OS will page the contents of memory to the disk and can be brought back into physical memory when it's needed. Since no two process can reference same dynamic link library at any instance of time, Windows OS does memory mapping that speed up the sequential file and the data is not randomly sorted. Also enable for memory sharing between the instances. 32-bit Windows OS memory architecture. Let's understand how Windows 32-bit operating system is built with respect to memory allocations. The memory space is shared between the active application and the kernel in the 32-bit Windows operating system. The default configuration provides 4 GB of addressable memory space which is divided equally. 2 GB allocated to the kernel and the 2 GB to the user application memory. So this is the image or the figure of the memory management of a 32-bit Windows OS memory architecture. So the 64-bit Windows OS memory architecture explains as follows. The memory space is shared between the active application and the kernel. In the 64-bit Windows operating system, the default configuration provides 16 TB of addressable memory space, which is divided equally, 8 TB allocated to the kernel and 8 TB to the user application memory. The kernel further divides the memory for system PTEs, paged pool, system cache, non-paged pool like images, etc. Refer to the figure 5.2. The process utilizes kernel virtual address space 32-bit with application installed in Windows OS run as virtual 2 GB Windows on Windows space, whereas 64-bit process has to be dedicated space. So this is the image or the figure of the 64-bit Windows OS memory architecture. Now let's look at the device management. A control panel application that enables user to view and control the peripheral or external devices that are connected to the computer in the Windows OS is known as a device manager. Device Manager first appeared in Windows 95 and later improved in later versions of Windows OS. Nowadays, all the peripheral devices are coming with drivers pre-available. This allows Windows OS to automatically identify the peripheral device and install the driver of the external hardware. Users can view, control, and monitor the health of the device connected to the system using Device Manager. Okay. Device Manager displays different statuses of the external hardware that is connected to the system, like disabled devices typically displayed in gray color. Hardware is not working properly, typically displayed using exclamation, hardware not recognized in typically displayed using a yellow question mark, device setting manually configured in typically displayed using the blue icon. Device manager opens up the possibility of connecting different variety of devices to the computer like biometric devices, cameras, external or extended displays, network adapters, external graphic card, etc. So this is how a device management works. So now let's look at the file management in the Windows OS. A sequence of bits, bytes of related information that is stored in the secondary storage devices like optical disks and magnetic tapes is known as a file. In the prior versions of Windows 95, Windows File Manager was used to manage or organize the secondary storage. In the later version of Windows OS, Windows Explorer is used to manage or organize the secondary storage data. Windows Explorer enables users with a GUI to navigate through different folders and access different extensions as shown in the figure 8.8, 8.1. So this is how the file management works in a Windows OS. Windows Explorer provides the user ability to copy, move, rename, and search on files and folders. Users will be able to define attribute for files and folders like read-only, system, hidden, archive. Using Windows Explorer, users can format the disks and share files over the network and can delete the files from the folder structure. The deleted files can be still on the disk unless deleted from the recycle bin. Now let's look at the security management of the Windows OS. Windows OS security management mainly focuses on four things, that is the LSA policy API, the password filter API, the safer API, the service security attachments API. The local security authority allows to set up a local security policy of the system by maintaining information about all aspects of local security. Passwords policy set up the password change notification, utilizes password filters. When a user requests for a password change, LSA reaches out to the password filters to validate the new password and update the filters that password is modified. Security management. Safer API execution checks the security policy for the approvals when an external system begins execution. Before an executable or active content is loaded or run, the Safer API can be called. Mostly, the applications that use Safer API are those that can transfer files from for example, like email, instant messengers, Bluetooth, transfers, or third-party apps. Cloud storage, web applications, Microsoft has started the Safer API implementation from Windows XP. And the service security attachments features helps to manage the security configuration. Microsoft Management Console simplifies the analysis of the system security. Not every application can be managed through MMC. Standalone applications and other customized applications have their own security configuration. Users have to extend the functionality by writing MMC for the application that handles specific service security tasks. A specific service security task attachment consists of two components: an MMC snap-in extension that implements the attachment user interface, and attachment engine that processes service specific security configuration and analysis tasks. The user interfaces. User interface is the gateway for users to connect with computers and perform desired actions. Windows user interface has started text-based user interface as the Windows version improved graphical user interface came into the picture. Windows operating system is designed based on desktop concept. Whether the user can place all his data on the view panel, user can arrange his desktop however the user wants. The taskbar can be placed at any corner of the desktop. Windows operating system graphical user interface enables user to see multiple applications running at the same time on the display and sharing information with each other. The implementation of Windows graphical user interface is limitless. User in the current user in the current time, multiple desktops and display to perform complex computation, or play video games. Microsoft developed desktop accessories or widgets to help the user for faster computation. All these applications can spread across the desktop or even topple on each other. Windows OS runs the application in the background and makes the data content available to the user as required in a single session. As the version on Windows GUI is improving, the more transparent look is brought into picture. For example, if the cursor or a pointer is moved to the bottom right corner, all the running windows are minimized and the desktop is visible to the user. User can drag drop any windows, folders, or data contains like images, songs, documents. So components as below are introduced in the Windows OS. These are the different components which are introduced in the Windows OS, which is the desktop components Windows. In desktop components, they have start menu, desktop, programs, login screen, boot modules, documents. In Windows, they have my computer, folder, control panel, operation like minimize, maximize, and close. So, what comparison is involved in this line of business? What companies are involved in this line of business? Microsoft is one of the leading operating computer operating system. So, as we know, the Microsoft is one of the leading computer operating system for developers and sellers. Microsoft Windows operating system is used widely across the globe in all industries. Nevertheless, there are other companies in the market who are developers of computer operating systems. Every company has a different methodology of operating systems. Linux operating system is one open source operating system created by Linus Torvalds in 1991. Linux operating system available for everyone to use. Users use and modify software as per the business needs. The recent developments made Linux more user friendly and released the Red Hat operating system. Apple company is also a world leading computer operating system. Android Inc. developed Android OS for mobile operating system. It was developed by Palo Alto and later upgraded by Andy. Now, Android is the leading mobile phone operating system. Amazon Firefox OS developed mainly to support Amazon products. Chrome OS is Linux kernel based on operating system developed by the Google. Raspberry Pi operating system is a Unix based operating system and absolutely free. Future direction and conclusion. The era of computers has changed the course of human thinking and perspective. On a daily basis, humans rely on computers 75%. The journey started with a simple calculation to compute and to predict human behaviors. We are already automating most of our daily activities from groceries to home automation. We started with a big computer and trimmed them down to our palm size. The initial operating systems are text based and could only do simple operations considering current technology. Now everything is graphic based touch sensors and voice commands. Undoubtedly, computers are helping humans in almost every way in day to day life. I only see an increase in computer usage and understanding more about operating systems can help in developing better operating systems in terms of performance and memory usage. Thank you.